Okay, so let's begin with the paper 1, question 1, part B. So this question is a little bit difficult, and also just to set a little backstory for this whole paper. So I do have students that actually sat through this paper during the past 2 weeks, and I've already graded their scripts. And right now, I'm actually using these questions as like what I see my students did very, very badly at. So I feel, or my own personal opinion will be that these students, or majority of the students will also struggle with these few questions. That's why I specifically chose these few. The slightly simpler questions I will not be touching because either they are too simple, not worth the time going through right now, or because majority of the people can actually get it. So there's actually no point. I'd rather tackle those questions that are on the little bit more difficult scale. So let's do with the first question, which is 1 part B. The equation of a curve is given by y equals to the cosecant square of x over 2 minus pi over 6, where x is between the range of 0 and pi over 2. Given that x is increasing at 0.3 radians per second, find the rate of change of y with respect to time when x is equals to 5 pi over 6. This question here is a very prelim kind of question, not really for the O-levels. Simple reason is because in your syllabus, you're not really required to know any trigo differentiation with powers. Most of the time, we will only deal with single trigo terms, like for example, sine, cosine, tangents. Very rare we will see sine squares, cosine squares, tangent squares. But if you're going for school prelims, chances of testing is actually pretty high because as we all, I hope you guys know that the differentiation of trigo terms is with powers is just a very basic chain rule. And that is basically the formula that we're going to apply today. I hope everyone knows your basic chain rule. So there's a mnemonic that I like to say whenever we do this kind of differentiation, which is power bring down, power minus 1, differentiate the trigo ratio, differentiate the angle. So 4 things. I repeat one more time. Power bring down, power minus 1, differentiate the trigo ratio, differentiate the angle. So these are the 4 things that I will need to do for all trigo differentiation that has a power. So let's start the question officially. So the first thing I'm going to do is that we notice that cosecant, this cosecant down here is something that we haven't learned yet at the O-levels. So we're going to change this cosecant into something that we have learned before. So it's either tangent or we change it to either 1 minus cotangent square or 1 plus cotangent square, or we're going to change it into 1 over sine square. Both of them will work. The easier one will obviously be the sine square. So what I'm going to do is do it this way. So y is equals to, okay, let me write it slightly bigger. Okay, y is equals to sine power negative 2 of x over 2 minus pi over 6. I'm choosing instead to use power minus 2 instead of doing 1 over sine square. Simple reason is so that the differentiation looks a lot cleaner, a lot easier to do as well. So we're going to differentiate. So I'm going to practice whatever mnemonic I mentioned just now. So power bring down, power minus 1, multiplied by the differentiation of the trigo term, oops, sorry, it's 2, not 3, my bad. Multiplied by the differentiation of the angle. So this should be the full differentiation. And if you simplify this expression down here, you will get this. So the cosine of x over 2 minus pi over 6 divide by sine cube x over 2 minus pi over 6. So this is the function here. And actually, if you go and try to simplify this down again, it's actually cotangent, cosecant square. And in actual fact, if anyone were to further your math, okay, you go further, like for example, A-levels or even further, you will actually learn that cosecant square formula is actually this. You don't actually need to know it now, okay, because you can be derived that. So the question is asking you to figure out the rate of change of y. So this is something that I teach my students to do, is to always identify what the question wants. So from here, we can tell we want to find dy over dt. So this is what we want to find. So right now, what I'm going to do is I'm going to write whatever we want to find into two different fractions. So this is the other version of the chain rule. So dy over blank is over dy over blank multiplied by blank over dt. And then the two blanks down there must be the same term. And we go back into the question to check what is missing. And if we check, we'll realize that x is actually missing. So this should be the x. And now we can actually substitute the value of x in. So we're going to do dy over dt when x is equals to 5 pi over 6. And we just need to compute this using this function here, substituting x as 5 pi over 6 multiplied by 0.3 radians. And then you will get your final answer. It's actually something in an exact form. Answer is negative 0.6 radians per second, exact form. So negative 0.6 radians per second. So for this kind of questions, I want to stress a few things. Number one, whenever you're doing this kind of rate of change question, always identify what you want to find right here. The question will always be very clear as to what you want to find. Number two, if let's say your x is decreasing, okay, x is decreasing at 0.3 radians, take note that the 0.3 that you use in your computation must be negative, as you're going to take into account the decreasing rate of change. Very last thing, at the very end, please remember to write a unit or write a completing statement to answer the question. For this kind of questions, because this is talking about a curve and a point moving, you don't really need an explanation statement. But for questions where it's like, if you have done your TYS a lot, you know that one of the most popular questions will be a sphere balloon, have air leaking out. So always have a final statement to complete your computation. So say, like, for example, the rate of change of air exiting the balloon is something over something or whatsoever. So these three very important things for rate of change questions. So this wraps up question 1 part B. We'll move on into question 2. So when I set this paper for my students, I made a promise to them that I will do 15% challenging questions and 85% questions are doable. So I don't know how many here have actually tried through the paper. If you actually did and you found the paper to be a little bit on the difficult side, it's totally fine, because this paper is set with the intention of a little bit more challenging, because I introduce questions that are a little bit more out of the norm, a little bit more difficult to find if you were to do your own research online and whatsoever. These kind of questions here are a little bit more unique to the spectrums that they are from, hence why they are in this paper. Now, the reason I'm doing that is because it's to prepare students for prelims. For O-levels, it won't be this challenging. It may be possible, but I highly doubt so. So question 2 is actually one of them that is on the more difficult scale, especially because this question combines 3 to 4 different chapters in one entire question. The one that I want to focus on will be question parts A and part C. Part C especially, part C is where the most challenging aspect from the question comes in, but part A and part B are relatively okay. But for part A, you do need to know what to do, or else the chances of getting stuck is very, very high. So I'm going to basically summarize the question. This question shows 2 curves. You have curve A and curve B. Curve A cuts the x-axis at the point M, and curve B cuts the x-axis at the origin and the point N. And both of these graphs, they will intersect at the point P. Your objective is to search out for the values of A, B, and C given that A, B, and C are integers. So the problem with this question is that a lot of people didn't know how to start the question, when in actual fact, there is a very important piece of information in the question that is not so obvious. So I'm just going to guide you through the question as the solutions have already been released. The first thing that we need to do is to search out for C. So C is step 1. Step 2 is to find A. Step 3 is to find B. Of course, the question didn't tell you that you need to take this route. So take note that C is what you need to find first. And the thing that you're going to use is actually this point here, the point of origin. As we know that the curve passes through the origin, this means that x is equals to 0, y is also equals to 0. So what I'm going to do, let's solve for C first. So we're going to search out for the coordinates of C. So we're going to sub in 0, 0 into B. And we're going to have 0 is equals to 0 squared plus B0 plus C, and C will be equal to 0. That should be the very first thing. And if you actually know, if you know your equations of curves very well, you will know that for a very standard quadratic equation, ax squared plus bx plus c, the value of c is actually your y-intercept of the curve. Don't trust me? Think about it. When you passing through your y-intercept, right? What values do you substitute in? You substitute x equals to 0. So when you sub in x equals to 0, your ax squared and your bx will actually vanish. Whatever you're left with is just your c. So the c constant down there is actually your y-intercept. Same thing like straight lines. The next step after this is to search out for a. And this a value is a little bit more challenging to find because this method requires a little bit of thinking to get it out. So first thing, take note that this x-axis down here, we have an axis down here. This curve cuts the axis at one point. So you need to think of the chapter that helps you deal with cutting a curve at exactly one point. And the chapter is actually discriminant. B squared minus 4ac. So the discriminant chapter here will help you, and you will help you break down this curve A such that you will get b squared minus 4ac equals to 0. You're going to have an unknown of a single A. So b squared minus 4ac equals to 0 because this axis is tangential to the curve. Sorry. So we're going to search out for coordinates of A now. So we're going to say that b squared minus 4ac is equals to 0. So this is the one that's a bit challenging, as there are quite a few people that couldn't spot the discriminant aspect of this question. So this is a squared minus 4 times 1 times 36 equals to 0. A squared is equals to 144. A is equals to plus minus 12. Now at this junction, a lot of people actually go and happily reject the negative answer. And is that true? No. So a lot of people did the rejection of the negative answer and claim that A is positive 12. But if you do that, you're going to face a very big problem. So how do you tell actually which value of A do you choose? If let's say you were to choose A as a positive number here, so y is equals to x squared plus 12x plus 36. Your next job will be to search out for M. What we're going to do is that at M, we know that y equals to 0. So we're going to factorize this equation. And we're going to be left with x plus 6 squared. And we're going to solve for the x coordinate for M. And what is the value? So this whole thing is equals to 0. X will be equals to negative 6. Is this possible? No, because M is on the positive side of the x-axis. So there's a contradiction here. So it is not possible for x to actually be, A to be positive 12. A needs to be negative 12. So students will actually ask, how do you actually identify which value of A is possible? What you need to do is to sub it back into the curve to actually verify if your computation is correct or not. So we're going to reject the positive answer. So here, reject the positive answer. And A is negative. Next, we're going to search out for the coordinates of M. So coordinates of M, we're going to sum x equals to 0. Sorry, y equals to 0, I bet. And we're going to get y is equals to x squared minus 12x plus 36. X minus 6 whole thing squared. So therefore, this thing is equals to 0. X is 6. The coordinates of m is 6, 0. What's the purpose of searching out for m? Because we need another point such that we can use the second or the first curve, such that we can find b. And the other point that we're interested in is point n. So we're going to use point n. And which point are we interested in? And which piece of information do we use? This. N is the midpoint of OM. So if we know that m is 6, 0, n will be 3, 0. So n is 3, 0. And now we can actually compute by substituting n0 into the curve. So we're going to find b now. So we're going to sub n30 into curve b. And we're going to compute that b is equals to -3. And those are your answers. So this question is pretty long, pretty tough. And I hope others are able to do it. Next, we're going to go on into part B. I'm just going to review the answer and the method of how to do this question. We are looking for the coordinates of P. Right here. To find the coordinates of P, we are looking for the intersection point between two curves. And the intersection point can always be computed using simultaneous equations. So just remember that, for example, if you have two straight lines looking for a point of intersection, it's always simultaneous. Same thing for curves, same thing for any type of graphs out there. If you're looking for the point of intersection, it's always simultaneous. So this one I'm not going to go through because the simultaneous is very simple. Answer is 4, 4. I need this fact for the next part of the question. So I want to focus a little bit more time on part C. So let's read the question. A new graph has an equation of y equals to mx squared plus nx plus r. Graph C has a vertex turning points at P and passes through M. Find the values of M, N, and R given that M, N, and R are integers. So the difficulty of this question is that there are no numerical values given to you. There is literally no piece of information given to you. And you need to pull magic out of thin air. First thing I'm going to do is I'm going to draw a very simple scenario on what is going on. Oops, sorry. So I have a quadratic curve down here. And this is, sorry, we do not know that, but we know this. We know that this is M. And we know that up here is P. So what is the thought process throughout this? It is pretty clear that we have not learned at the O levels how to solve equations of 3 unknowns. Currently, right now, we have an equation of 3 unknowns. So we think about it. Under the simultaneous chapter, if we have 2 unknowns, x and y, to solve x and y, we need to form 2 sets of equations. For this one here, we have 3 unknowns with M, N, and R. So this means we need 3 equations. So that is the first thing that you need to realize. You need 3 equations. What are the 3? So a very important concept that a lot of people didn't know is that, actually you guys know, but a lot of people didn't apply it in this case, is that if you have a point passing through a line, the points must obey the line. I'll give you a very simple example. If you have a straight line down here, let's call this equation y is equals to 2x plus 1. So any point along this line y equals to 2x plus 1, let's say, for example, 1, 3, must obey the line. When you substitute what x is equals to 1, y will be equals to 3. It's the same thing for any other coordinates out there. Let's say, for example, 2, 5. Same problem. Okay, if you substitute x equals to 2, you should get y equals to 5. It's the same logic here. You have points P and points M. You can actually substitute both points P and M into the equation of the curve separately to get out your first 2 equations. So that's what I'm going to do. So I'm going to work out P first. And if you were to substitute in, I'll just give you the equation straight away. R is equals to 14 minus 16m minus 4n. Equation 1. And m, same thing, I'll give you the equation first. So you'll be negative 36m minus 6n. Equation 2. The most difficult one will be to find where is my last equation. Where is it? Okay, that's where you need to notice a very important keyword in the question. It's a little bit unexpected, this particular keyword. There's a very special keyword in this question, and a lot of people didn't expect to use this method to solve the question. Now, if you're currently in Sec 3 and you're trying this question for the very first time, the chances of getting this question is not high. You won't be able to get it because you do need something that you only learn in Sec 4, which is differentiation. So this is the keyword vertex turning point. This here means that dy dx equals to 0. And dy dx is going to be a very smart method to use. Very simple reason is because we're going to differentiate this curve. And the first thing that is going to vanish is the value of r. Whatever we are left with is just m and n. And we can use that into these two equations down here. So what I'm going to do is, first thing, we're going to claim the vertex. So we know that dy over dx is equals to 0. So this means that 2mx plus n equals to 0. We have that dy over dx when x is equals to 4. This is equals to 0. And we have a new equation, 8m plus n equals to 0. Equation 3. So we have three equations now of three different unknowns. You just need to perform your simultaneous, and then you will get out your answer. In case you're confused about how to do the simultaneous, do these two first. Make equation 1 equals to equation 2. And then you'll form an equation in terms of m and n. After that, substitute this new equation into number 3 and solve for m and n. Once done, substitute the value of m and n into r, and then we will get the answer. So this question is pretty challenging. If you couldn't do it, it's actually fine. Okay, I don't actually expect many people to be able to get this because of the nature of this difficulty of this question. So this wraps up question 2. If anyone has any questions, feel free to just pop it into the chat, and then I'll be able to answer them as I see them. The next question I want to look at will be question 4, which is the maxima minima question. So this maxima minima question is a very standard maxima minima question. However, this question is a little bit on the evil side because if you cannot do part A, you cannot do part B, but you still can do part C. The problem is the part A and the part B, which I want to talk a little bit about, as I do know that there are quite a number of people that actually cannot get the answer for part A and part B. Most of the time for such questions, they will always ask you to show part A, most of the time. There are rare instances where the questions are not like that. And an example is the one in front of you. The worst kind of questions is where there's not even a part A, and you yourself need to know to go straight into part B. Later, when we tackle part B, I'm going to actually explain how do we do those kind of questions that deal straight away, jump into part B. We're going to talk about this type first, which only deals with like part A asking you to express something, part B asking you to solve or show a particular equation. So what we have here is a machine part that consists of a cylinder and an upside down cone. The cylinder has a height of a h and radius of r, and the cone has a radius of r with an angle of pi over 3. We know that the volume of the whole machine part is equal to 50 pi. Express h in terms of r. How do we do this question? I'm going to share some of the more common mistakes that I saw during my mock exam. One of them is that a lot of students memorize the cone formula as 1/3 pi r squared h. And we see that in this question here, there's a h as well, which is the cylinder. So a lot of people actually just go and write 1/3 pi r squared h plus pi r squared h and then they happily just go and combine the two together, and then you happily solve for h. No, it doesn't work that way. The cone and the cylinder do not share the same height. So let's just stress this very important thing. They do not share the same height. And I'm going to call this height A, as we know that they are different. We're going to apply our EMATH method here as to how to find an equation in terms of A, because apparently that's the thing that we're missing right now. What do we need to find? We are given an angle, and we know that the height of a cone with respect to the radius is always perpendicular. So the method is actually trigo. So we do need to apply a little bit of trigo, basic trigo here, to work out what is the value of A in terms of R. So what I'm going to do is to compute this question now. So we're going to let the height of the cone be A. We're going to use tangent. So tangent pi over 3 is equals to A over R. We're going to solve for A. Oh, sorry, R over A over R. Sorry. A is equals to root 3 of R. Tangent pi over 3 is root 3. So root 3R. Now we're going to compute the total volume, as the question tells you about total volume here. So we have 50 pi. This is equals to the cone, 1/3 pi R squared. Now take note, this is A. So this is root 3R plus pi R squared H. And now we just need to make H the subject of this equation, and we are done. So H is equals to 50 over R squared minus root 3 over 3R. Sure. Oh, not sure. Solve. This is the answer. Of course, you can write it in any other form that you want. Just make sure that it is close to this. If you do not get anything that is of this nature, it will be impossible to solve B, which is a very good transition into part B. So the question is asking you to figure out what is the total surface area of the machine parts right now. And you're asked to show this particular equation. First thing I'm going to do is I'm going to solve the question first. After that, I'm going to explain how to do questions that only jump straight into part B with no filler part A there to help you. The question is telling you to find the total surface area. So we go back into the diagram to look out for some important pieces of information. Number one, whenever you're looking for surface areas of any figures, no matter is it AMATH or EMATH, we will always look at whether the figure is it closed or open. Very important. If let's say the cylinder is open, then there's no top. If the cylinder is closed, then there should be a top. Take note that this is a closed cylinder. So there's actually a piece up here. This is a piece that a lot of people forgot. So there are 3 sections to this total surface area. The circle up here, the curved part of the cone, the curved part of the cylinder, and now the slant part of the cone. The top 2 are easier to find. The more difficult one is the bottom. How do you figure out the slant portion of a cone? And we recall our EMATH formula is pi RL. Pi RL, where L is the slant height of your cone. What is the slant height of the cone? You need to use trigo one more time. As the length that you're missing down here is the hypotenuse, we have R, we have an angle, therefore we can use trigo one more time. So I'm going to go back into the question. Let the slant height be L. We're going to use cosine. So the cosine of pi over 3 is equals to R over L. L will be equals to 2R. Why is it 2? Because cosine pi over 3 is cosine 60. Cosine 60 is half. So 1 over half is just 2. We're going to work out the total surface area. So total surface area is equals to the circle, pi R squared, plus the curved part of the cylinder. So that is the circumference multiplied by the height, 2 pi R. Now take note, H. And if you look at your equation there is actually no instance of a H. So we're going to substitute part A's answer right here. So this is 50 over r squared minus the root 3 over 3r, then plus pi r square, right? Or sorry, pi rl, which is 2r. And then you just need to simplify this down and you will definitely get your answer of pi r squared over 3, 9 minus 2 root 3 plus 100 pi over r. So the showing in the center, I'll leave it to you to do on your own. It's not difficult. You just need to expand and you will get your answer. Right now, I'm going to actually explain or give you a little tip as to how to do questions that do not have a filler part of part A in between. The tip is very simple. At the O levels, all maxima minima questions will always be of one unknown. So if you look down here, there's only one unknown, which is r, which is a variable. When you move further, that's when questions start to get a bit more difficult. There will be more than one variable. For the O levels, because you only know single variable differentiation, your equations down here will always be in terms of one variable. When you do maxima minima questions, there will always be more than one variable. Okay, like this in this question, there are two, h and r. So this will tell you that h has been used as a substitution tool. And now we know that we need to find an equation in terms of h first, and then we will substitute into the last formula to solve for whatever we need to show. So that is the tip. You need to know which variable is your substitution tool so that you'll be able to substitute in. I don't see many questions that are phrased straight away jump into the last part. There are out there, but those are on the more difficult scale. So I hope after this tip, more people will be able to do such questions. We're going to move on into part C. Okay, part C is actually very simple, so I'm not going to touch. Just want to do a very, very quick recap because the question is asking you for stationary points. So we know that dy dx is equals to 0, or in this case, dA dr is equals to 0. We're going to determine the nature. There are two steps of determining nature, two workings that you can use, either the first derivative test or the second derivative test. How do you tell the difference between the two? You just look back at the equation. If you feel that the equation is very easy to differentiate, then by all means, go for the second derivative test. If you see that your equation is a little bit more difficult, like for example, fraction over a fraction, and you need to use your quotient rule, and the quotient rule becomes very complicated, then please perform the first derivative test. Just recall as well, for the first derivative test, it is 100% foolproof. For the second derivative test, it is actually a 33% chance of failure. If your d2y dx squared is equals to 0, please remember that this is a inconclusive result. You do not need to correction tape your answer. Just state in the paper that your answer is inconclusive. Perform the first test. And this is the recap for maxima minima questions. We're going to move on into question 5. Okay, this is proofs in plane geometry. This is one of the more difficult questions in this paper, and is also one of the very common pitfalls for many, many students. The part that I want to focus on is actually part A and part B. I don't really care part C and part D because those two are pretty easy. I'm just going to leave it as it is. I want to touch part A and part B. In the diagram, ABCD are points on the circumference of a circle with center O. EDFG is a tangent to the circle at D. Given AB is equals to BG and DF is equals to FG, you need to prove that ABD is an isosceles triangle. When I was marking this question, there were actually quite a few people that actually managed to prove this very well, but it took a very long approach. They used a lot of alternate segment theorem. They used a lot of funky things to manage to show that this is actually an isosceles triangle, which is actually pretty good. The method that I'm actually going to use is a little bit more interesting. It's a lot faster, and it will actually help you compute the whole question very quickly. So the first thing is to establish where is this isosceles triangle. So what I'm going to do is I'm going to draw the line that will help me with this. So I'm going to use this line here. So isosceles triangle means that AB is equals to BD. So there are two ways to prove an isosceles triangle. Number one, you show that these two angles, you show that these two angles here are equal, or you show that the lengths are of equal length. Either one, to prove that this is definitely an isosceles triangle. How do you do this question? So the way I'm going to do it is I'm going to use the AMath things that you have learned, okay, which is the midpoint theorem. And this question applies the midpoint theorem pretty well. It's just a little bit more difficult to spot. So this is the midpoint theorem. So how do you do this question? Now, first thing is I'm going to establish one angle first before I claim my midpoint theorem, which is angle ADG. ADG is definitely 90 degrees. Why? Two reasons. Number one, EDFG is a tangent to the circle. Number two, OD is a radius, and therefore ODG is 90 degrees because tangent is perpendicular to your radius. You cannot anyhow claim that any line that is touching the tangent line is going to be perpendicular. No, you must be very clear that the line that is touching the tangent line must be the radius of the circle. So that's step one. I'm going to claim that angles ADG is equals to 90 because your tangent is perpendicular to your radius. Next step, we're going to perform our midpoint theorem. So to recap the midpoint theorem, what does it say? For the midpoint theorem, it states that for any triangle, two of the sides, if you can find midpoints along these two sides, and these two midpoints are joined by a straight line, this straight line will be parallel to the very last side, and also this midpoint line will be half the length of the last line. This is the midpoint theorem. We're going to apply this midpoint theorem here and where. So the first thing the question states that AB is equals to BG. So these two lines are equal. Clearly, this is a midpoint. Looking at AOD, this is a radius, this is a radius. O is the center of the circle. Obviously, O is the midpoint. So this means that if I join OB, there is a midpoint. So this line here will be parallel to DG. So we can just state now by the midpoint theorem. It is good to also tell people that O and B are midpoints. So it's very clear where you claim your midpoint theorem from so that you don't mess it up. Okay, so therefore we know that OB is parallel to DG. What's the point of doing this? Is so that I can establish angle AOB. Angle AOB equals to 90 degrees. So this is the reason, is because of parallel lines, corresponding angles. So what's the purpose of doing this? Okay, I'm going to show you something very interesting that's happening in this question right now that a lot of people actually didn't know. So what is this interesting thing? If you look at this figure very, very carefully, and I'm going to look at specifically OB. So this line down here. There's a very special name for OB right now, other than radius. Okay, I repeat one more time. There's going to be a very special name for OB right now because we know that AOB is 90. There's a very special name for OB. Okay, I'm just going to review what it is. This is a perpendicular bisector. If you're not convinced, let me explain this to you. This is a perpendicular bisector because of two simple reasons. Number one, perpendicular bisector properties will be perpendicular to the line that you're cutting, obviously. And number two, perpendicular bisectors always cut at the midpoint of any line. And O is the midpoint. So OB is a perpendicular bisector. Why do we claim perpendicular bisector? Now, if you recall your perpendicular bisector properties, any two lines that start from the vertices of the line. Okay, so if you have your line, and let's say the red one is a perpendicular bisector, any line that is starting from the vertices of this orange line will always be of equal length. And I believe this is one of the theorems that you learn in EMath, so that you can use this theorem here, and perpendicular bisector properties. So this is the full solution. Those two lengths are equal, hence this is an isosceles triangle. So what we're going to say that AB, we're going to say now that OB is a perpendicular bisector. And therefore, AB equals to DB, okay, because of the properties. And therefore, triangle ABD is isosceles. Now, of course, whatever I'm doing right here, whatever I'm writing here is actually very short form. And because I'm doing this is because I don't have a lot of time. If you want to see the full way to actually properly write the proof, please refer to my solutions that has already been uploaded. So this is the solution for this question. So this question is a little bit on the difficult side. If you cannot do it, it's actually fine. Please go and practice plain geom questions, especially because a lot of students are not good in plain geom because you cannot spot the figure, or it's either your EMath congruency similarity, your angle properties, and your properties of circles are not strong, or a lot of people just have a lot of fear in this topic and then they don't touch the topic at all. It's pretty detrimental if you do so, because there's a guarantee question every single year in O's, and you do not know the difficulty of the question. Sometimes it can really be very tough, and you're going to throw marks away just because you never practice enough. If you need resources on this kind of questions, my monthly series every month have always like 5 to 6 different questions there. Or if you do need, you can always reach out to me to actually get some questions, more questions for practice. The next one I want to focus on is actually part B. Now, I'm not going to compute the whole thing. I'm just going to provide a little bit of insight as to how to do such questions. Now, take note that there's a difference between part B and part D. Okay, these two parts. So a little tip in case your schools actually never tell you this before, or your tutors never tell you this before, is that whenever you have equations that look like this that you need to prove, okay, first thing is do not get scared, because I do understand that every time you see such an equation, people will start to highlight the line in the diagram, and then they see like, oh my God, there is no relationship at all. Do not panic, because there is actually a way to do it. Whenever you see squares in this kind of question, so like this, they will lead you to different paths, because there are only two methods in the universe that deals with squares very, very clearly like this. The first one is your corresponding ratio. So your corresponding ratio is those that you have like A over B equals to C over D using your similar triangles, then you cross multiply. Those kind of questions always have a square. Okay, those are how you tell that you need to use corresponding ratios in the question. The second method, which is a little bit more obscure, is Pythagoras Theorem. So this question requires Pythagoras Theorem. So in exams, if let's say you're very stuck and you do not know how to start, always look for right triangles and always look for similar triangles. These two will always help you. And I also mentioned that both parts are actually different. What's the main difference between them? Notice that there's a minus sign here, and notice there's a multiplication here. Most of the time, I am willing to say about 90% of the time, multiplication questions are always similar triangles. Plus and minus are most of the time Pythagoras Theorem. Okay, so I've shared some insight about such questions. Hope that this will help you do this kind of questions in the future. So don't get scared when you see such difficult questions out there. We're going to move on from plain geom. Now, I know in my list, I mentioned that I wanted to go through question 7. Okay, but actually my intention for 7 is just to talk a little bit about it. I don't really want to go through 7. A few simple reasons. Number one, 7 will never ever appear in O's, and also I highly doubt that it will appear in any school prelims unless your school really don't like you and they want to set something really tough, then 7 can come in. The question 7, I didn't get it from any school prelims. Now for context, all these questions are from school prelims that I've modified a little bit. Question 7 and question 8 are a little bit more unique because question 7, I actually got it off an Instagram account. I cannot remember which account, but I saw it on Instagram one day and I thought the question was pretty cool. Question 7 part B, I got it off TikTok, as I know that TikTok now is a very popular thing. Just to share, I'm going to sound like a geek after this, but yes, my TikTok FYP is a lot of math. Okay, so please don't judge, okay, but that's just me. Most people is other content, mine is mathematics. So I found B on TikTok, I found A on Instagram. A is slightly more difficult than B. B is a more common question that is more found in eMath. This question is pretty difficult. I'm not going to go through now because I do not want to explain some of the intricacy to the question. If you need the solution, please refer to my answer key. Okay. Now for 8, I also got this off Instagram over one of the accounts. I think it's a pretty famous math account. I think it's on Curious Math, if I remember correctly, just to shout out them. So how do you do this question? This question is a little bit more on the ballpark of O-levels, more on the ballpark of prelims. That's why I've decided to choose this question. And I'm pretty happy that some of my students actually managed to get this correct. I'll just share some statistics. This question about, okay, a total of 28 of my students took this paper. About 4 people managed to get part B correct. This question, 1 person got it, which is pretty impressive. And question 8, about 13 people got it correct. So you can kind of see the difficulty in the question. Of course, the one with the 1 person, that one is a very unique case. The person that got it is pretty smart, so he managed to get it. For question 8, it's a pretty common O-level question or prelim question. So yeah, it's a more common question now. So let's go through this. Now, number 1, if you read such a question, right, and you have an instinct to solve for X and Y, there's something wrong with you because it is impossible. There are a lot of this kind of questions floating around right now, and a lot of students still have that concept in their head that you need to find X and Y. Like you die need to find X and Y. No. For some cases, right, you actually don't need to find X and Y. This is one of the cases. Because number 1, it is impossible. There's no way you can find X and Y because you're only given 1 equation and you're given 2 unknowns. It is literally impossible. The way to do this question is you're going to perform a very special form of substitution. And where is this? I'm going to show you now. I'm going to use logarithm formulas down here to simplify this down and get rid of all of the logarithms. So this is log x plus y over 3 is equals to log. First formula I'm going to use is xy over 2. At this junction, I'm going to go through some of the more common mistakes that a lot of students make during this question. Number 1, this number 3 down here. A lot of people will just cross multiply the 3 across to the right-hand side. And this is wrong. The very simple reason is because the 3 is within the logarithm. That is not correct at all. Number 2, this one here. This is a very famous mistake that many students will make. And you will claim that log of x plus the log of y equals to the log of x plus y. So this is something that a lot of people will write whenever they are very desperate during exams and do not know how to start. And this kind of rubbish will start to appear. This is wrong. Please do not do this in exams. You will get the question wrong. Okay, the addition of logarithm terms is always the multiplication of the x and y term. Please do not add. It's the same thing as the minus sign. Okay, this is rubbish as well. Log x minus log y equals to the log of x minus y. This is rubbish. Please do not do this during exams. It is supposed to be log x minus log y equals to log x over log y. And then for log x plus log y is log x y. Please, okay, this is a very common mistake. Please do not make such mistakes in exams. So we're going to go here and we're going to carry on the question. Now, of course, on the right-hand side, now there's a random 2 in the denominator. I don't want that. I want to get rid of it. So I'm going to throw the 2 over. I'm going to get log x plus y over 3 equals to log x y. In order to get rid of the logarithm, this is another very common mistake in logarithm questions, which I will mention later in paper 2, which is that a lot of people like to cancel logarithms anyhow. This is one of the cases. So if you were to go and expand your logarithm terms and you never expand properly, if you want to quote unquote cancel your logarithms, you need to make sure that both sides of your equations only contain one logarithm term. It means you cannot have a log something plus log something equals to something, and then you say something plus something equals to something. This is wrong. It is not allowed to. You're not allowed to do that. You need to group these two terms together first, then you can cancel. So same thing, I will mention this again later as it's a logarithm question upcoming. So later we'll talk about that. So the log of x plus y over 3 whole square equals to the log of xy. And right now I fulfilled what I said. There's both sides, there's only one logarithm equation. So I'm going to have x squared. I'm going to expand straight away as well. So x squared plus 2xy plus y squared over 9 equals to xy. Another very common mistake, a lot of people forget to square the denominator of 3, and you get it wrong as well. So x squared plus y squared equals to 7xy. Equation 1. What's the reason? You will see why in a while. So the question asks you to show a numerical value. So x over y plus y over x squared plus y squared over xy. And notice the numerator is x squared plus y squared. So instead of substituting find x, find y, then you solve, no, it is impossible. You sub in the whole of x squared plus y squared. So that this is just 7xy over xy, and the values would vanish. And the answer is 7. So a few learning points for this question here. Number 1, whenever you see one equation with two unknowns, please never ever go and solve for one or the other unknown. It is impossible. And number 2, whenever you see such questions, make sure that you find the correct substitution tool so that you are able to substitute properly. This is question 8, and we're done. We're going to go on to the last question, which is question 9, this properties of circle question. The remaining questions of this paper are pretty simple, so I'm not going to touch. Let's just look at this circle question. The one that I want to focus on is actually part C, as part C is not very easy. Part A and part B are pretty simple. So what I'm going to do is that I'm going to just review the answers for part A and part B, and then I'm just going to jump straight into part C. For part A, the radius is actually 4.47 or root 20. And the coordinates of the center is actually 4,1. This is very simple. You're just modifying your general form here, and you can get your answer. I'm going to talk maybe about 1 minute on question part B to share the concept. What is a chord? Okay, first thing, let's define what is a chord. So I have a circle. Oh my God. So we have a circle. Okay. So the definition of a chord is a line that cuts through the circle twice. So like this. I'm going to just randomly call a chord like this. And we need to find what is the equation of this chord. Now, equation of a chord is actually pretty similar to the concepts of finding the equation of a tangent to the circle. It is pretty close. I would say it's pretty close. What is the methods? So step 1, you need to know your center. And you need to know your midpoint. And what is the relationship between the center and the midpoint? Perpendicular line. The line that joins these two lines together, perpendicular. Okay, so it's the same thing for your tangent property. If the line's on the outside, your line that is going from the center to the tangent, this will be perpendicular as well. And you can use perpendicular properties to solve the question. You have the coordinates of C, you have the coordinates of M. So you can find the gradient of Cm, then take the negative reciprocal to find the gradient of the chord, and then find your equation straight away. This is the method to do this question. It is close to identical to finding the gradient of a tangent to the circle. The one I want to focus on is part C, as this question is not as simple. So let's look at it very carefully. If P is a variable point on a circle, so if you've never seen what is a variable point before, variable point means that this point P can move around the circle. Find the maximum area of triangle APB or ABP. So some important keywords in the question, maximum. Now, a lot of people will see maximum and then the first thing they think is differentiation. Okay, there's no differentiation aspect in this question. Very simple reason is because at the O levels, you're not taught implicit differentiation. So there's no way you can differentiate your equation of the circle. So that is definitely out of the question. The only way that you can do it is to actually identify how to find the biggest possible triangle in this circle. I'm going to draw a scenario right now. So I have a circle like this. I'm going to have a chord AB. You need to be able to identify where is this point P, such that this circle is going to be as large as possible. And this links back into your circle properties. Where is this point? This point is going to be at the most extreme end of this circle with reference to your chord. So it's going to be somewhere here. So this particular point, I'm going to draw the triangle right now using another color. So like this and like this. Oops, sorry, this is not straight. Yep, there you go. And this point P is actually at a very, very unique location. I'm going to connect those two lines together like this. And what do you realize? There's a center. And here. This is actually the center, and this is M. So we can claim one very important thing right now. P, C, M. They are collinear. In order for point P to be at the maximum point and this triangle to be as big as possible, we need P, C, and M to be collinear, and we need this to be perpendicular. This is the only possible way to get this answer out. So the question now is, how do you find this area? So let's write the equation first that we need so we can identify what do we need to find. So area is equals to half times, okay, this is A, this is B. So half times AB times MP. Looking at this equation here, we need to find AB definitely. So AB is an unknown at the moment. Now, MP makes up of, sorry, you see MP? Yeah, MP. So MC plus CP. Looking at this equation right now, we have two things that we are missing. AB and MC. CP down here, this is the radius. Square root 20. Okay, I received the question. Let me check the question. How do we know that this is the maximum area? Circle properties. So if you, okay, number one is that P is on the circle, right? So what I can do is I can move this point around the circle, and you go and think about it. The only possible way that this triangle is going to go as large as possible if this point is on the most extreme end. It's actually part of your circle properties, and you're using angle at center equals 2 times angle at circumference to actually kind of explain this property. Okay. If you need some time to convince yourself, what you can do is you can go into Desmos, the graphing app, and go and chart out this whole diagram. And you go and see yourself. You go and move this point P around, and you go and find where is the most possible point for it to be maximum. And you will realize that it's at your perpendicular line. Okay, so I hope I answered your question. So the area is equals to AB times MC plus CP. We are short of AB and we are short of MC. MC is not difficult to find because we have the coordinates of C and M. So I'm just going to give you the length. Okay, don't want to calculate. So length equals to the square root of 12,105. How do you work this out? Please remember that this is Pythagoras Theorem, or x2 minus x1 squared plus y2 minus y1 squared. This is the formula. The main problem right now that a lot of people have is, how do you find AB? This is the main problem. Oh no, how to find? Now, I've received a few different methods. Of course, the most common method that some people choose to do is to do simultaneous with your line and your circle. Now, of course, sure, by all means, it is entirely possible. But that is going to be a very big pain in your backside. Because if you realize your equation here, okay, sorry, let me review the equation also, just to show. The equation here is y is equal to 16 over 7x. plus 4 over 7. So this is the equation, and this is your circle. So to find coordinates A and B, we'll simultaneously these two together. You can try. Go ahead. But this is definitely not worth 4 marks. It's way too challenging. The chances of making mistake is very, very high. So I don't recommend this method. There is another method that we can use. So this method actually links back a little bit into your E-math. So I hope that you guys have seen this figure before. If you have attended my lessons before, or if you have heard me go through E-math mensuration before, you have heard me say this particular figure before. And this is one of the most common shapes out there. You can form a right-angled triangle within this figure so that you can find a lot of things very, very quickly. The trick to doing this question is to join C and B together, like this. And when you join C and B together, the triangle that we are interested in is CMB. Why? CMB, we have this. Do we have this? Yes. We have CB, and this is the radius. A lot of people will forget this fact, and then we can Pythagoras this answer, so we can get out MB. This is how you do this question. So we're going to work out MB right now. So I'm going to compute everything from now on. So MB, we're going to take the length of CM. Okay, so this is the square root of 12, 1 over 5 whole thing squared plus, oh, sorry. I made a mistake. So this thing should be, there we go. Sorry about that. Okay, it's supposed to be the radius of the circle. So which is the root of 20 holding square minus this thing. And I will get something quite beautiful as well. So it's the root of 7, 4 over 5. One thing I want to say is that if this is the very first time you're attending my lessons, so just take note that for me personally, I love exact form. I hate decimals. So you will never ever see me compute decimals out like this. It's the same thing that I do for E-math. I would never ever type decimals out unless really, really necessary. Simple reasons. Number one, the chances of writing so many numbers, making mistakes, very, very high. Number two, I do not want to use rounded off values because it will make my answer more and more inaccurate. So I always love exact form. If you look at all my answer keys, it is always the same logic. I always use exact form unless absolutely necessary. I despise decimal points to the core. So that's why all my answers are like that. So we have MB. We know that M is the midpoint of AB. We can compute AB. So AB is just double of this thing. And right now we're done. So we can solve the question now. We can find the area. So area is equals to half 2 square root of 7, 4 over 5 multiplied by the root of 12, 1 over 5 plus root 20. Final answer, 22.2 units squared. And we're done. So this is the full question. I hope everyone is convinced as to why the area needs to be maximum and P, C, and M must be collinear. And this is how you do this question. So I'm going to wrap up paper 1. This is the end of paper 1. The remaining questions are not too difficult, so I leave it to you to do it on your own. My answer key should be pretty self-explanatory enough. If let's say you're facing any issues, then you feel free to just message me to ask me any questions. Right now, we're going to go into paper 2. So I hope some of you have actually tried through the papers, and the general sensing is that paper 1 is a little bit more difficult than paper 2. Paper 2 is a bit tougher. For simple reasons, as paper 1 contains more topics where most students cannot do. So that's why paper 1 is a little bit more difficult than paper 2. I do not know whether the O's will be like this. It really depends on how SCAB decides to set their papers. The first question I want to tackle will be question 1. So I have 6 questions I want to do here. 1, 3, 4, 7, 8, and 10. So question 1 will be this question here. Sorry, receive the question. what's the exact difference between paper 1 and paper 2? Or to be very honest, there is no difference. The main difference is that paper 2 questions can go up to maximum of 12 marks. Paper 1 maximum is 10. Both timings all the same. Question types is literally all the same now. But I would say that paper 2 questions are a little bit longer, a little bit more demanding because of the mark allocations. As paper 2 has lesser questions, but your questions can be like 10 to 12 marks. For paper 1, is about 11 to 13 questions, where your mark allocation is about 9 to 11 marks in one question. No, it's different from EMath paper 2. Assuming they are talking about the old syllabus, which is the 4048 syllabus, this year's syllabus, then no, it's different. The paper styles are completely different. For EMath paper 1 are short answered questions, paper 2 are longer questions. For AMath paper 1, paper 2, they are close to identical. The questions are the same. It's just that there are more parts in paper 1 or paper 2, and there are more marks in paper 2 per question. That's all. That's the main difference. Good question though. No one has ever asked that before. Okay, question 1, part A. So this question is not very easy because it's a single straight line of a statement with no numbers, and people are expected to pull stuff out of thin air. Okay, the question is, find a possible number x when added to its reciprocal gives a minimum sum. Actually, if you were to use logic, the answer is just 1. So this is a logical question. It's 1. But of course, writing 1 like that with no working, you're only going to get the answer. You're not going to get any method at all. So how to do this question? The answer is differentiation. So here, differentiation. So I'm going to share a tip that I shared yesterday with my students, or whoever attended yesterday, is that a very important skill for both EMath and AMath is to actually identify which topics you are actually covering at that point. So let me explain what I mean. So because the nature of how the papers are designed, right, all the topics are jumbled all over the place. And they will never be like, oh, okay, question 1, quadratic function, question 2, equation inequality. No, you'll never be like that. It will be like suddenly differentiation, then binomial theorem, then logarithm, then differentiation again, then kinematics, then jump back to something else. Yeah, it will jump all over the place. The thing about exams, right, is all about storing the information in your head and then going into your head, selecting the correct hard drive to use in the exam. So a very important skill is choosing which hard drive to use in exam. Imagine your head like a database, and you have many slots of all the different chapters that you have learned. You need to be able to choose which drive to use to apply which concept. And this is a very important skill that requires time to master. So a suggestion is right now, for anyone that is like preparing for prelims or anyone that is preparing for O's, one very good way to practice, other than doing the questions and doing, is just opening up any random prelim paper and just start identifying what topic they are from. You identify topic, you identify question type. If you're able to identify these two, and you yourself in your head, you're able to process what kind of methods you need to do, then to be very honest, the computation is not necessary. Unless you're the type that your computation, you're horrendous at it, then of course, keep on practicing your computations. But if you know that your doing is already there, you're pretty solid at it, your problem now is just about spotting questions. Practice that. Go into any paper, just look at the question, read the question one time, identify which topic the question is from. And then you know, oh, okay, this is a differentiation question. I know I need to perform differentiation. That's all. Trust me, this is a very important skill that a lot of people will sleep on. Trust me, do it. And it will really help you in the very long run when you're going into your other subjects. Even in your chem, your bio, your physics, or anything, right? You can also do the same thing. It's like, for example, chem. It is very obvious when it's an organic chem question, or when is it a QA question, or when is it an electrolysis question. You must be able to look at the question, pull out the correct database to use the information from the question. Okay, so enough of me rambling. Let's move on to this. So this is a differentiation question. Now the question says that you have a positive number x added to its reciprocal. So I'm going to call this y equals to x plus 1 over x. And we're going to differentiate. So dy over dx, this is equals to 1 minus 1 over x squared. And we know minimum sum, this is equals to 0. So this is this, and we're going to solve for x. So x is equals to plus minus 1. Question says that you need to have a positive number. So you're going to reject negative 1. Answer is 1. It's a very simple question, but it's a very good opening question because a lot of people couldn't do. And yeah. Part B. Calculate the maximum value of 3uv squared given that u and v are two variables such that u plus v equals to 15. Now, this question here is also differentiation because of the word maximum. But one of my students actually did guess and check, which is a pretty impressive thing to do, to be very honest. Yes, this person did guess and check, and he got very, very, very lucky, and he managed to get the answer. To be very honest, I didn't accept it because guess and check is by right not allowed. Okay, it's allowed, but you must justify your guess and check. For this case, there's actually no reason to use guess and check. You can actually work it out very, very simply. First thing is to let this be equation y. I'll call this y. So y is equals to 3u, y equals to 3uv squared, and I have an equation down here. What I'm going to do is that I'm going to substitute this equation down here into this. So let's do that. So I'm going to maybe just use u. So I get y is equals to 3u, 3 of 15 minus v squared. And this will compute to 45v squared minus 3v cubed. Next, we are going to differentiate. So we're going to do dy over dv, and this is 90v minus 9v squared. Now, we know that the value of y, which is the function out there, is a maximum. So this means that dy over dv equals to 0. So this function is equals to 0. 90v minus 9v squared equals to 0. V equals to 0 or v equals to 10. Now, for this case, it is not possible for v to be 0 as we want v to be maximum. So we will reject the solution, and therefore we can find u. U will be 5. And therefore, final answer is 3, 5, 10 squared. Answer is 1500. So this is the solution for this question. It's not as difficult, but maybe just a bit unique. That I don't think many people have seen this before. Okay, question 3. So this is the next question that I'm interested in, which is question 3. Logarithms. Yeah, okay, correct. Logarithms. So okay, so the topics that I'm left with is logarithms, polynomials. Question 7 is what? Okay. Question 7 is R formula. I just want to talk about one part. Question 8, which is the differentiation integration portion. That one pretty important. And question 10. So these are the question 10 is differentiation and integration as well. So these are the last few topics. I know I never touched trigo today, but because the trigo questions in these papers are not difficult, so I don't really want to do trigo. Okay. So let's look at question 3, which is down here. Okay, logarithms. So I want to go through logarithms because logarithms is always a topic that a lot of people are very weak at, even though it's not the most difficult thing in the world. So let's look at especially the first question. The first question, majority of my students got it. Yeah, majority. So the way to do it is very simple. Notice that your powers are your unknowns. So we're going to log both sides. So we're going to take LG4. Okay, I'm just going to throw the base down straight away. So LG4, x minus 1, LG7. And we're going to solve for x. So we're going to factorize. We're going to get LG4 minus, plus LG7. Okay. Oh, yeah, plus LG7. Wait, minus, right? Sorry, minus. Is equals to negative LG7, and we're going to solve for x. So x will just be LG7 over LG7 minus LG4. Final answer is 3.42. Okay, so the rule of thumb is this. Whenever you are looking at a question and you have problems finding your powers are your unknowns, always take logarithms on both sides. Then it will help you throw your powers down. So this is the tip for this question. For the bottom one, this is interesting. So we have 2 log 4 5x squared minus log 8 4 minus x whole cubed equals to 1 plus log 2 1 minus x. The thing I'm going to do for this question, as I'm running out of time, I'm going to actually show you how to simplify the logarithms. The solution you can do on your own because it's not difficult. What is the tip for this kind of questions? Very, very simple tip. First thing, notice that your bases of your logarithms are all numbers that are related to the number 2. 4 square, 4 is 2 square, 8 is 2 cube, and 2 is obviously 2 power 1 now. So this is a change of base question. Whenever you see such questions like this, we always change base, and we always change to the simplest possible base. So please do not change to all base 8. It doesn't make sense. Change to base 2. So what I'm going to do is I'm going to keep the 2 in front for simple reason. Later you'll see why. 2 log, log 2 5x squared over log 2 4 minus, now the cube up here, I'm going to throw it down. So 3 log 3, log 2, 4x minus 1, 4 minus 1, 4 minus x, over log 2 8 equals to 1 plus log 2 1 minus x. So notice that this here, this is 2, this is 3. Not division, those lines are just telling you what they are. So log 2 4 is 2, log 2 8 is 3, and voila, cancel. And we are left with something like this. So what I'm going to do now is I'm going to group the logarithms together. So I'm going to stress a point that I mentioned just now at paper 1, which is that if you want to cancel your logarithms, sure, no problem. You can only cancel your logarithms if left-hand side got 1, right-hand side got 1. You cannot have 2 side by side and then you go and cancel. No, cannot. You're going to get it wrong. Combine the 2 first. This is a minus sign, so we're going to do a division. So this is log 2 5x squared over 4 minus x equals to, now the one on the right, there's a 1 down there. I can change 1 to log 2 and then combine. So log 2 1 minus x. And we're done. So both sides contain a log 2, we can cancel. So 5x squared over 4 minus x equals to 2 1 minus x. Okay, and then the rest of the question you can do yourself. 2 things I want to mention. Number 1, okay, just to mathematically correct myself, I do not cancel the logarithms. I'm just equating the bases. I'm equating the indexes. That's all. Okay, so sorry if I offended anyone that is learning math. Okay, sorry, on a further level, I did not cancel the logarithm. I am equating the indices. Okay, that's number 1. And number 2, a very common mistake down here. Take note, the square. This square down here is only powered to the x. There are people that throw the square down, become 4 log 4 5x. That is wrong. The square is only supposed to be powered to the x and not anything else. So just be very careful. Please do not make that mistake in doing exams. The last one that I want to touch for this question will be part B. Sketch the graph of y equals to 2e to the power of negative x and y equals to 3 minus e to the power of x on the same diagram. Find the x coordinates of the points of intersections of the 2 graphs. Now, this question is a little bit on the sneaky side. Let me explain why. A lot of people can draw. The drawing of the diagram is not difficult. But there's a very big problem with this question. You do not actually know how many points of intersection these 2 graphs have. Okay, so it's got 3 different options, obviously. 0, 1, 2. Okay, there's no other possible way, of course. So how do you tell? That's why for this question, you actually do need to find the points of intersection first, and then you can determine and draw the graph accurately. So for this question, it's very special because the way I've designed this question is that I purposely squeeze both parts into one part. I never do B part 1, B part 2. if I were to do P part 1, P part 2, I will ask you to find the x coordinates first, then ask you to sketch. I will never ask you to do the other way around, as it is pretty bad for me to do that. But for this case, I combine everything into one. So it is your job to do either one first, because it doesn't really matter. You can do the back part first, then you can do the top. So how do you do this question? Now we are looking for points of intersection. I mentioned this just now at the very start of the session. If you are looking for the points of intersection, simultaneous. So we are going to simultaneous these two equations together. 2 over e to the power of x is equals to 3 minus e to the power of x. Now at this stage, if we are about 2 months to O levels, and if you at this stage right now, you cannot tell what kind of equation this is, please go and practice your logarithms. This is a quadratic equation. Okay, if you have issues still spotting that this is a quadratic, please go and practice your logarithms and go and start being able to spot such questions. This is a logarithm question. So I'm going to change all them to a. So 2 over a is equals to 3 minus a squared minus 3a plus 2 equals to 0. A minus 2, a minus 1 equals to 0. A equals to 2, or equals to 1. We're not solving for a, we're solving for e. Ex is 2. Ex is 1. X is ln 2. X is 1. X is 0, sorry. So these are the two different answers that you can use for your solution. And this will tell you automatically that there are 2 points of intersection. So we know that now when I draw my graph, I need to force these 2 points of intersection. The first one I'm going to draw is 2e to the power of negative x. This is a very simple graph to draw. The more difficult one will be the other one. So let's draw it first. So line. Okay, let me push this a bit lower. Okay, so the first one will be like that. Okay, it'll be something like that. Okay, mind my bad drawing. I'm so sorry about that. Okay, this is the solve. Line x. If you have issues drawing this, please go and memorize what are the different combinations of logarithm graphs. Okay, take note that in the syllabus for A Math, the new syllabus 4049, there are a few graphs that you need to remember how to draw: quadratic functions, exponentials, logarithms, the natural logs, and the last one is your trigo graphs. These are the 4. Nothing else, I think. Yeah, nothing else. So number 1, this graph must be asymptotical to the x-axis. You cannot touch. Go very, very, very close. Cannot touch. The next one I'm going to draw is going to be the other graph. So the other graph is a little bit more difficult. Wait, I'm just going to force this higher so it's a bit easier to draw. Okay, so the other graph actually looks like this. Oh my god. Okay, I'm trying my best. Sorry. Oh my god. Hang on. Okay, wait. Okay, I can adjust this. Okay. So the graph, okay, I know it looks very, very bad. I am so sorry, but just bear with me. Okay, this is 2. No, sorry. Yeah, this is 2. And this point down here, this is long 2. Okay, a few things that has happened. So I want to label a few things. So the first thing is that this is the curve y equals to 2e to the power of negative x, and the other one is y equals to 3 minus e to the power of x. Please take note that if you are drawing 2 different curves onto one diagram, please remember to always label. If you don't, it'll be pretty detrimental, because they will just anyhow choose and then you'll get the question wrong. The last thing that a lot of people will forget to draw is the asymptote. Okay, there's an asymptote down here. Okay, so there's an asymptote at y equals to 3. Yeah, y equals to 3. Why is there an asymptote? Yes. Okay, because the original negative e to the power of x graph is asymptotical to the x-axis, and because there's a plus 3 there, you shift the graph up by 3. So your asymptotes also auto shift up by 3. That's why there's an asymptote at 3. Okay. This answer. Let's have a question. Why is I just explained? Yeah. Why is the 3ex graph like that? Yeah, I just explained it. Okay. Yes. What do you mean by flip? Oh, okay. Sorry, let me just answer that question. E to the power of, wait, oh, negative e to the power of x. The graph looks like this. Yeah. Yeah. Okay. So this is the answer. Okay, question 4. So for question 4, the one that I want to look at is actually for part B. Because for part B is not very easy. So I'm just going to give you the intuition behind the question. I'm not going to go through part A because A is very easy. Let's look at B. When a cubic polynomial gx is divided by x minus 1 and x plus 4, it leaves a remainder of negative 12 and negative 37. When gx is divided by x squared plus 3x minus 4, the remainder is ax plus b. Find the values of a and b. So there's a few things that should pop in your head when you're doing such a question. You're looking for two unknowns, so obviously there is a simultaneous aspect in this question. So the first thing we're going to do is we're going to write out all the information in this question. So the question says that g of 1 equals to negative 12, and the g of negative 4 equals to negative 37. Where did I get these pieces of information from? I got it from the first line, because the question says that g is divided by x minus 1 leaves remainder of negative 12. This means when you substitute x equals to 1, you're going to get the remainder of negative 12. Next thing I'm going to do is use the second statement here. So the second statement, I'm going to write out my division algorithm. Okay, I don't know whether you guys know what this is. If you do not know, please refer to my free notes. It's written there. Okay, so division algorithm states that gx is equals to the divisor, which is, let's call this dx, qx plus rx. Okay, this is a very important equation. Please remember, gx is your polynomial, dx is your divisor, qx is your quotient, rx is your remainder. All equations can be written in this form. Same thing for numbers, in case you didn't know. So I'm going to write this properly. X squared plus 3x minus 4 multiplied by the quotient, which is currently unknown at the moment, plus ax plus b. So this is where you need to realize something very interesting has happened. X squared plus 3x minus 4. Can you simplify this down? You can. If you break this down, you get x minus 1, x plus 4, x minus 1, plus ax plus b, like this. And if you realize, yeah, they're all the same. So this means what? Right now, we're going to choose values to substitute into gx. And what's my objective for polynomial questions? Is to always get rid of the quotient, because this thing is a burden and we cannot find. So how to get rid of the quotient is to always substitute values into the x such that the quotient will vanish. So a value that you choose is g1. So when you submit g1, okay, the whole quotient vanishes. So you're going to get a plus b equals to negative 12. The one is substituted here. For the other one is negative 4. So this is b minus 4a equals to negative 37. So when you substitute the negative 4 and you substitute the 1 right here, okay, you will get your equation from here. Okay, so this is how you do this question. You have two sets of simultaneous, solve your answer. Okay, then the whole question will be done. Question. Is there another method for this without using this formula? No, don't have. This is the only way. Oh yeah, sorry, I think I forgot to mention. If anyone has any questions, right, if possible, okay, if you're shy, then fine, nothing, no problems. But if you don't mind, put the message as open message so everyone can actually look and then also can learn from the question as well. Okay, because there are no such thing as bad questions. So if possible, if really cannot, then it's fine. Yeah, I'm fine with it. Okay, but thank you for your question. No, there's no other way. This is the only way to do this question. Okay, thank you for the question. So the remaining part, the simultaneous, I leave it to you to do on your own. Okay, try it. It's not, honestly, not difficult. Let's move on. The next question I want to look at, okay, I'm going to deviate from whatever I said just now. I'm going to go into this. This is 6 part B. I just want to make one comment about this question. Yep. Okay, so this has something to do with logarithms as well. I just want to stress this thing here. Here. Okay. This is something that I realized a lot of people actually didn't know, and a lot of people are making mistakes at this particular equation here. There is a very big difference between ln x squared and ln x squared. These two are not equal. They are two very, very different things. Because you can do this, but you cannot do this. This is wrong. It's not allowed because your square is to the ln as well. You're going to square the ln function. So the whole thing must be squared. For the ln x squared, the square is only referenced to the x. That's why you can throw the 2 down. So a lot of people, when they differentiated this, they give me 2 over x as the first derivative, which is wrong. That's not the correct way to do it. The first derivative for this is chain rule. It should be 2 ln x over x. Okay, if you tried the question. So just want to stress this very important point down here. Just be a bit careful. We're going to go into 7. So the one that I want to go through is part A, because this is the most difficult part. The rest are actually pretty easy, so I'm not going to touch. I'm only going to touch part A. This one here. So this is a pretty unique question that I found. Pretty old question. This question is more than 10 years old. Pretty cool question. That's why I decided to set it. P, Q, and R are 3 points on a circle such that with coordinates of the following form. So there's a lot of coordinates down here. I'm not going to read them out. Show that RP square is equals to 4 plus 2 root 2 sine theta plus 2 root 2 cosine theta. This is an R formula question. The main problem is actually part A that a lot of people cannot do. So how do you do this question? Now, there's something that I mentioned during the proofs in plain geometry section of my lecture today, which is that the RP square. So whenever you see square terms like this, it should automatically red flag to you that this is a Pythagoras Theorem question. Okay. So another example of questions that uses this like squared concept is surds. If let's say you're dealing with those kind of application-based surd questions, then whenever you see a square, those should tell you automatically that you're dealing with Pythagoras Theorem. It's the same thing here. We are going to deal with Pythagoras Theorem here. And something that a lot of students did during this paper was to say that triangle RQP is right angle. No, this is not true. How is RQP right angle? That's definitely not true. We are looking for this. So I'm going to draw a line, and I'm going to do it in a very easy way and foolproof way. Now, I'm actually pretty happy with my students because majority of the people actually managed to get this question correct. But I wanted to go through because I know this question is a little bit difficult for people that are not good at spotting diagrams. So what I'm going to do is I'm going to draw down like this. And I'm going to draw all the way down. Very simple reason is because we have the coordinates of R and P respectively. So I'm going to trace out, just keep on tracing out like this. And I'll explain why I'm doing that in a while. So I'm going to draw my right triangle, which is going to be here. I'm going to label all of the blue lines that I've drawn so far. So in case you didn't know, let's recap a little bit of EMF vectors at the same time. If you didn't know, all of these coordinates down here, okay, are something like your position vectors. So for example, if they give you R44 like this, this is basically saying that you are 4 units away from the origin. So if you recap vectors right now, this is 4, 4. Okay, so if you were to draw this on the Cartesian coordinate system, 4, 4. In case you didn't know, okay, just want to share this point because I know of people that didn't know this fact, that the coordinates down there are always with reference to your origin, point of origin. So what I'm going to do is I'm going to label where all of these lines are to help you show where is this right angle triangle. This is 4, oops, sorry, this is 4, this is 4. We know that P, okay, we look at P, this is the x coordinate, so it means that this length down here is 5 plus root 2 cosine theta And this length down here, this is 5 plus root 2 sine theta. So given that it looks like this, I'm looking for the orange, which is here and here. Can you see how to do it? If you know that from the y-axis to P is 5 plus 2 root 2 cosine theta, and from the y-axis to R is 4, the bottom adjacent side is going to be 5 plus root 2 cosine theta minus 4. Same thing for the other side. If the whole height of P is 5 plus root 2 sine theta, and from R is 4, and we're looking for the orange piece up there, it's just 5 plus root 2 sine theta minus 4. And we will get the answer. That is how you do this question. So we're going to apply Pythagoras Theorem right now. I'm going to do everything in a single step because I'm lazy. So RP squared, is equals to like this. So this will be 5 plus root 2 cosine theta minus 4 squared plus 5 plus root 2 sine theta minus 4 squared. And if you were to simplify this expression down, you will get 1 plus root 2 cosine theta squared, 1 plus root 2 sine theta squared, and we can expand. So 1 plus 2 root 2 cosine theta plus 2 cosine square theta, plus 1 plus 2 root 2 sine theta plus 2 sine square theta. I saw a question. Give me a while. I'll respond to it in a while. So this is the function. Now, how do we continue? This and this. So we all know that sine square plus cosine square equals to 1. So those two is basically 2. So it's 2 plus 1 plus 1. Answer is 4 in front. Plus 2 root 2 cosine theta. Oh, you need to answer the question, right? So sine theta plus 2 root 2 cosine theta. Sure. Okay. So yes, I received the question. Give me a while. Can we use Pythagoras theorem for the center of circle and RP? No. How? How do you do that? Yeah, I don't think your question makes sense or your point makes sense. So let me explain. The center is here. Who says that RC, or let's call the center C, RCP is 90. No one says so. And there's no way you can do the question if you do center like that. And there's no indication of where the center is as well. So no, that's not correct. Good question. Interesting question. Okay, so this is 7. I'm not going to go through the rest because it is pretty easy. So let's move to 8. Question 8. I'll go through the whole question because this is a very common question that a lot of people cannot do. So let's just go through. So the first part, okay, the differentiation of this. So even this differentiation is not very well done in general. You need to show that d over dx of tangent x sine squared x is equals to that formula. So in case you didn't know, this is product rule. So we're going to perform product rule down here. So the function is equals to sine squared secant square x plus tangent x. Remember, I mentioned just now at the very start about the differentiation of squared terms. Okay, squared triple terms is a mnemonic that I always say. If you want, you can say it with me. Because it sounds like teaching primary school. Sorry. Yeah, you can say it with me. Power bring down, power minus 1, differentiate the triple ratio, differentiate the angle. 4 things. I repeat one more time. Power bring down, power minus 1, differentiate the triple ratio, differentiate the angle. 4 things. So let's perform. 2. Sine x, power bring down, power minus 1, differentiate the triple ratio, differentiate the angle, which is just 1 now, so I'm not going to write. And you got this. Okay, I'm going to simplify this function right now. So sine square secant square x. If you didn't know already, this is obviously tangent square x. Let me explain. Secant square x is 1 over cosine square, and sine over cosine is tangent. So this is tangent square x, very simple. Next, for this one is a little bit tougher. Some people cannot spot this. So tangent x, a tip is to change the tangent x into sine and cosine. So this is sine x, cosine x over cosine x. And there's a 2 in here. So, ta-da, cancel. We are just mathematically accurate. So we'll get 2 sine square x, and this is what we have in front. The tangent square x, we know formula, right? Is secant square x minus 1. And we're done. The main problem that most students have is this part, the differentiation of this. So just be careful. I just want to mention one thing. For me right now, because I'm not doing a lot of people like to use the UV table thing. I'm not doing it because I don't need it. So if you do need it, then by all means, please do it and do it properly. Okay, so I won't show it during my lessons because I personally don't like the UV table because I think it's too slow. So it's up to you guys to do whatever floats your boat. Okay, this one. So part B, this is the one that I want to talk a little bit about because I know the difficulty of this question. I know how difficult these kind of questions are, and a lot of people are very, very bad at these kind of questions. So I'm going to teach you, in case you have never attended my lessons before, I'm going to teach you the way that I do it. And this method works for me. Whatever your school teaches you, I know school teaches it in a slightly different way. I don't really like the way schools teach it because I don't like the way that they manipulate things moving around. To me, it's a bit very cumbersome way of doing the question. For me, I like to do everything just on the right-hand side, and it makes things look very neat, in my personal opinion. For everyone out there, if you follow your school, you follow your school. Okay, this is just how I do it. So do not blame me if you cannot understand or what. I will explain it to the best of my abilities right now. The way I'm going to do this question is very simple. I'm going to copy the left-hand term. So this is pi over 4 pi sine square x. What I'm going to do is this. Now, for this kind of questions, you do need to remember that part A is a differentiation question. Part B is an integration question. And we're going to recall this very important concept right here. dy over dx. Oh, sorry. Let's write it as f of x and f of x. The baby fx is the base function. Capital Fx is after differentiation. Okay, so this is, let me just write here of the okay, never mind, because it's going to be very obvious. So what we're going to do is we're going to rainbow like that. Okay, this is dy dx. And to get back from capital Fx to base fx, which is the other way around, this is integration. So in case you forgot, this is the way to relate differentiation with integration. So if you have differentiated something and you reach a result, let's call this result A. You integrate your result A, you will get back to your original result. Okay, I received the question. Yeah, it is. The capital Fx is the same as f prime x, yes, correct. But for me, because I use capital Fx for reasons that I'm not going to explain because it's too difficult to explain. So this is the function. What I'm going to do is I'm going to use part A's answer. As I know that the derivative of this thing down here, or the integral of this red circle down here is this. Okay, so what I'm going to do is I'm going to leave a lobang is a hole, in front. Yep. Integrate pi over 4 pi. And then I'm going to write my 2 sine square x plus secant square x minus 1. And before writing the dx at the very end, I'm going to leave another hole. And don't fill up first. So what is the purpose of these two holes? If you look at this statement right now, this equation here, are they equal? Obviously not. These two are definitely nowhere equal. Your job is to make them equal. So how? Very simple. There's a sine square x here. There's a sine square x here. But this second sine square x has a 2 in front. But you don't want the 2 because the 2 down there makes it have an extra copy. You want to get rid of it. So how do you get rid of the 2? Now, a lot of people say you pull it out. No. What you're going to do is you're going to add numbers here and you're going to add things here. So you're going to put a half. By multiplying a half in front, the 2 will vanish. And now both sides of the sin x are equal. But there's still a very big problem. Your secant square x plus 1 minus 1. This is an extra thing. So if you have something extra, minus off. So we're going to minus secant square x. And then we're going to plus 1. Why plus 1? Because it's a negative 1. We need to counteract it to get rid of it. So if you write this full statement right now, so I'm going to change my underline color so it's a bit more obvious. These are the orange. The orange things are the new things I've added in. And if you look at this statement properly, you will realize that both sides are equal now. Because the half will counteract everything on the inside. And then the secant squares will cancel. The plus 1 minus 1 will cancel. And you're left with a sine square x. And both sides of the equations are equal. Voila. What we're going to do now is I'm going to split up this integral into 2 sections. The red portion, which is whatever is on top in part A, and the orange part, which is the new thing that I've added in. So half integrating pi over 4 to pi 2 sine square x plus secant square x minus 1 dx. I'm going to split up the integral. Okay, I'm going to pull out the minus sign as well and push the half in because the half is multiplied to everything. Pi over 4 pi secant square x minus 1. Whatever I've done here is just basic algebra. So I've done nothing fancy. The half multiply in and pull out the minus sign. This one you can do on your own. Nothing difficult here. After that, we know this from part A. So we're going to integrate this. We're going to get half tangent x sine square x pi over 4. And for the behind term, secant square x minus 1. This is not difficult to integrate because we can integrate secant square, we can integrate minus 1. So you will get tangent x minus x. Yeah. Pi over 4. And we're done. Simplify, substitute, you get your answer. Answer is 1 over 4 plus 3 pi over 8. So this is all for this question. The thing that I want to stress is this part here, this step here. I like to think that this is the cleanest way to do this kind of questions. The one that a lot of schools do is the one that they manipulate and throw things around. Then after that, they form out the sine square. You can choose to do that, of course, but just be very careful. Make sure that you know what you're doing. Okay, I'm not going to go through that method because I personally, I do not like it. So I don't preach that method. So do whatever you guys feel is the easiest. Okay, don't let me confuse you in case I've taught you something a bit different. One more thing I wanted to say, but I forgot what I wanted to say. Wait. Okay, yes. If you want another form of explanation for this kind of questions, you can refer to my free notes on the Overmark channel. So I'm just going to open it up very, very quickly. So don't mind me for a short while. Let me pull out the notes. Okay. So under my integration notes, here. So this section here. So I've actually done a very simple explanation of whatever I've just done right here. So if you want, you can actually go and look at it. This is slide number, no clue, slide number 89. Okay, so it's under integration. You can look for this particular section here. Then you can look through how I actually did the full working and how I'm doing this kind of variance. And actually at the back, another type, which is the one that deals with partial fractions. I believe it's 2 questions before this question in this paper. And I think this is the third one. Oh no, this is the other application, sorry. So there are examples here that I think will benefit some of you if this method actually helps you. Okay. Yeah. Hang on. Okay. So this is the question. And right now, to wrap up today's morning session, I'm going to complete question 10. So the whole entire question 10, I'm not going to go through everything. The part that I'm interested in is actually part part B lah. Okay, so I'm interested in part B, part 1, part 2, and a little bit of part 3. I don't really want to do the area under the graph because it's pretty simple. But let me see. Okay, never mind. I'm not going to do part 1. I'm just going to go straight into part 2 because part 2 is the most difficult part in this whole paper. So this one requires a little bit of explanation. So let me go through this very quickly. Okay, to give context for those that haven't seen this question before, the diagram shows part of a curve y equals to 2x plus 1 over 5 plus 4 root 4x. You have a line PR. This is normal to the curve. There's a point Q that cuts the y-axis, and S is a point directly below P. The question asks you to find the equation of PR. This one you can do on your own. It's a very simple way to do it. It's a very standard thing also. This part 2. This part 2 is pretty tough. So just want to give a little warning. I will explain this to the best of my abilities right now. So I hope everyone can listen up and understand what I'm doing here. Okay. Without calculating the area under the curve from x equals to 0 to x equals to 1, explain briefly why this whole inequality holds. The main problem with this is a lot of people didn't understand what this question means. The question is saying, why does this work? Why is it that when you integrate between 0 to 1 of the function, the value that you're going to get out is indeed going to be bigger than half of 1 plus root 5? But the problem is that the question is asking you not to calculate anything. So you're not allowed to actually calculate what is this value and to show that it is literally bigger than this. If it's the case, then obviously anyone can do it. Because of the fact you can't, there must be another way to do it. So how do you do this? This is actually has to do with the graph or the diagram drawn for you. Let's break down this whole equation. This thing down here. This thing down here is your area under the curve. I hope it's pretty clear. This is the area under the curve. What is this thing down here? Half 1 plus 1 over root 5. Of course, if you have seen my answers, then it's pretty easy lah. But if you have never seen my answers yet and you are wondering for the very first time, take some time to actually go and think as to where this thing came from. We're going to look at this diagram again, and we're going to search out for where is this half 1 plus root 5, 1 over root 5. Okay, I'm going to give you some hints, of course, and I'm going to guide you through how to find this point. So we're going to look for where the hell is this 1 half 1 plus 1 over root 5? Where did it come from? Okay, give you some tips. Number 1, this is dealing with area under the curve. So under the concepts of area under the curve, we know concepts about like taking shape minus shape, or we're looking for like a triangle minus something, or like a trapezium minus something. This is the main methods under area under the curve. So that should tell you that, okay, maybe this is an area under the curve, another area under the curve. Should be pretty obvious that this is the area under the curve, but what shape is this? You have a half. So a half links to triangle, links to trapezium. There's 2. Which is it and where is it? Okay. So you need to find where is this 1, where is this 1 over root 5. So I'm going to review the answer. The answer is actually here. I'm going to draw a line joining Q to P. And what I'm going to do is I'm going to pull out this diagram here, as it's a little bit difficult to see with the diagram given. So I'm going to make it a bit more extreme. So we have a curve like this. We have a curve like this. And we have a trapezium underneath. Okay. So I'm going to label all the different things. So this is Q, P, O, and S. So what is going on? Now, the first thing you should realize is that the curve is definitely above the trapezium. That should be pretty clear. I know in this diagram, because of the way it is being drawn, and it's going to be a little bit difficult to see, but I hope this is pretty clear as to what I'm trying to do here. So the first thing is I'm going to compute what is the area under this trapezium. So the area under this trapezium, let's write out some coordinates. This is 1, 1. This is 1. And to find Q, you need to substitute x equals to 0 into the curve. And when you sub in Q, you're going to get 1 over root 5. So how do you find the area of this trapezium? Trapezium formula is half times the sum of the parallel lines times the height. So this is 1 over root 5. This is 1. So the area is half 1 plus 1 over root 5 multiplied by 1, which is essentially half 1 plus 1 over root 5 lah. So this is the area there, here. And we can see that the area under the curve between 0 and 1, let's call this the orange part here. This is definitely bigger than the area of the trapezium. That is how you do this question. So what I'm going to do is I'm going to show you the answers that I've done. Hang on. Yeah. So this is the solution. This is how I've written it down. So I find the area of the trapezium PQOS. Then I get it down here. Then after that, I realize that it is actually half 1 plus 1 over root 5. And then I explain that area under the curve is that formula as well. And therefore, I say that it is pretty clear that the area of the trapezium is actually smaller than the area under the curve. Hence, it is safe to conclude that the following inequality holds. And that is how you do this question. Okay. So I hope this is clear as to how to do such questions. I don't, most likely prelims can come up with these kind of questions, but you guys will need to know how to do such questions. So this is just a very good explanation and how to do it. The very last thing I want to do is the part 3. Okay, there's a reason why I want to touch this very, very quickly. I know we didn't do the parts in front, but I just want to mention a little bit of things. Okay, so we're going to compute the area of the graph. So the area, okay, I just want to focus on one section. So the area, okay, is equal to the integral between 0 to 1 of 2x plus 1 over the square root of 5 plus 4x dx. Then plus the triangle. Okay, the triangle I'm not too concerned at the moment. So the one we can deal with it. The one that I want to talk about is here. So a lot of people reach this step and then they get stunned or they get very stuck because how to integrate that? Because there is no quotient rule, there is nothing that you can use here. You cannot split it up. There's no way that you can integrate this at your current level right now. So how do you do this? Now this question is not impossible. That's why there's a part A. Okay, you jump all the way to this part. Okay, there, here. So it is hidden in the question. It is here. It's just not obvious that you need to use this as a solution. So you realize, okay, it's exact same concept as the previous question that I just went through. You go one direction, differentiate. You go the backwards is integration. So if we were to integrate this thing here, we will get out this thing inside. And of course, the one on the right here is definitely not equal because it is 3 copies more. So you need to pull out the 3 first. So I'm going to show you my solutions to explain. So this is actually how you do it. The one that I was talking about is here. So we're going to integrate 2x plus 1 over 5 plus 4x. What we're going to do is we're going to pull out that we're going to put this 6x plus 3. But the problem is that now there's an extra 3 copies. To get rid of the 3 copies, we need to multiply by 1/3. Sorry, I said pull out 3. Sorry, no. We're going to multiply by 1/3 to get rid of that extra 3 copies. Okay. There's a typo here. 3 plus. Okay. But I changed it in the original document already. So this is the answer. Okay. That's basically it. So I've actually covered all the questions that I wanted to cover. So I'm going to stop the recording right now. So for those that are viewing this online, I got 2 things that I just want to say. For those here as well, you can listen as well. So 2 things I want to say. Number 1, all my free notes are already out for AMF. So you can go and use them at your own disposal. Anyone that got my curated notes as well, you can use it. Same thing, got a lot of worked examples inside. Another thing is that the mock papers are there for you to practice. The monthly practice questions are also all there, starting from February all the way to July. You can look for the solutions for February all the way to June. The July solutions will come at the end of the month. Okay, that's number 1. Number 2, a few things I want to share as well. So if you flip through the overmark Telegram channel. At the very top, I got this handwritten notes. Is this black color piece of paper? This is actually a summary guide of the whole entire syllabus. It's written in this form. I'm currently in the works of this year's version, which will be a little bit more eye-pleasing, I hope. This one is also just a very big summary of the whole syllabus. So in case you need anything that is very quick and very concise, you can use it as well. It's hidden above. I believe I uploaded it together with the mid-year mock papers that I released during the June period of time. The very last thing I want to say is that other than Chem and Bio, this round for the September round of holidays, I'm actually organizing a crash course for AMath and EMath as well, 3 different modules, 3 sessions, of course, for the whole syllabus of AMath and EMath, and then we will be going through my curated notes, and I will be going through different questions and helping you through the syllabus. So if you're interested, you can go onto the website and actually go into the channel and everything, so that you'll be able to find the crash course for either myself or for Chem or for Bio. It is just an advertisement for them lah. Okay, so that's all I want to say for the online people. So I wish you guys all the best. Okay, hope this video helps you. If you have any feedback, do leave it in the comments. I sound like a YouTuber now, but yeah, you can leave it in the comments, or you can just PM me on Telegram. Okay, goodbye. See you next time.